us discuss about nodal analysis with dependent sources. So how to apply nodal analysis whenever dependent sources are present in your electrical circuit. Nodal analysis for DC networks with dependent sources. That means the value of the source is depending on the network elements. So any changes in the net circuit elements will change the value of the source. Now see this example. Find the nodal voltages V1, V2 and V3. So there is a circuit given here. Here there is a dependent source whose value is 2Ix. What is Ix here? Ix is the current through this 2 ohm resistor. That means its value depends upon the current in 2 ohms resistor. That's why it is known as dependent source. Its value is depending on the current through this 2 ohm resistor. So let us do how it is to be done. The procedure is same. So first identify the nodes. So this is the reference node, right? And this is the principal node 1, 2 and 3. So 3 nodes there, V1, V2 and V3. 3 voltages you have to find, V1, V2 and V3. So if you apply KCL at node 1, how many branches? 1, 2, 3. So 3 branches, so 3 currents have to be there. So what is this current? 3 amperes is entering, so plus 3. Then this current is leaving, so minus, how much it is? V1 minus V2 by 2. Then this current is also leaving, which is V1 minus V3 by 4 is equal to 0. So let us simplify this. So this will become minus 0.75 V1 plus 0.5 V2 plus 0.25 V3 is equal to minus 3. Equation number 1, right? Next, let us write at node 2. So at node 2, this one. So what is the entering current? This V1 minus V2 by 2 is entering, so plus. Then this 4 ohm resistor is having a leaving current, so minus V2 by 4. Then this 8 ohm resistor is also having leaving current, so minus V2 minus V3 by 8 is equal to 0. Algebraic sum is equal to 0. So if you simplify this, I got 0.5 V1 minus 0.875 V2 plus 0.125 V3 is equal to 0. Say equation number 2. Now let us go for the node 3, to which the dependent source is connected. Same procedure. So nothing change here. So at node 3 write the KCL equations. So this is the entering current 8 ohm resistor. So it will be V2 minus V3 by 8. Then this is the leaving current, right? This is the current source, leaving current. So minus 2 into Ix. Its value is 2Ix. What is Ix here? Ix is nothing but current through your 2 ohm resistor. So what is the current through this 2 ohm resistor? V1 minus V2 by 2. So this Ix is to be replaced with V1 minus V2 by 2. Then if you see, there is a third branch here which is also coming towards the node. So it will be plus. So how much current it is? V1 minus V3 by 4 is equal to 0. So this is equation number 3. So 3 equations, 3 unknowns, V1, V2, V3. So if you solve these 3 equations by means of a calculator, then you will get the V1, V2, V3 values as 4.8, 2.4 and minus 2.4 volts, right? So this is how nodal analysis is to be done whenever dependent sources are there. So let us take one more example. So see this one. Find the node voltages V1 and V2. If you observe this figure, the circuit given, there is a voltage source connected between these two nodes. So actually what we are writing? KCL. KCL means we should know current. So what will be the current through this branch? If a voltage source is connected between two branches, how to write the current? So generally what we are doing? V1 V2. So V1 minus V2 by resistance we are writing. So if it is a voltage source connected, how to write the current? So this comes under a special category, that is super node analysis. Super node. So here we are forming a super node. So super node occurs whenever there is a voltage source between two nodes, principal nodes. Then how to do? How to do whenever a super node is to be there? We will form a super node by combining the nodes between which the voltage source is connected. So this is the super node, right? Super node. So take it as a node. Super node means it is a node. Take it as a node. Then write the KCL at that node. So at this node, at this super node, write the KCL. What are the currents entering? This 2 ohms current is entering. So what is the current expression to that branch? 4 minus V1, 4 minus V1 by 2, that is entering, so plus. Then this current is leaving 4 ohms. So leaving means minus. How much it is? V1 by 4, since it is the reference one. Then this is all a single node. Then this 8 ohms is also connected to your super node. Then what is the current in this 8 ohms? Leaving, so minus V2 by 8, V2 by 8. Then this branch current which is entering the node, so it is plus. How much it is? 2 amperes is equal to 0. So at this super node, that means I have treated it as a node and I have written the KCL equations at that node. Equation number 1, right? How many unknowns? V1, V2. 2 unknowns, I have written one equation. Then how to get the second equation? Take the super node. Take the super node, what you have written here it is. So super node, this is V1 and this is V2. Between these two a voltage source is there. So whose value is 18 volts. If you observe here, that means V2 minus V1 is 18 volts. So this is connected to the, V2 is connected to the positive terminal. So this is V2. So whereas V1 is connected to the negative terminal. So minus V1, which is equal to 18 volts. Which is equal to 18 volts. Suppose if it is like this, V2 and V1, then V1 minus V2 is equal to 18 volts, right? So but in our circuit it is given as this is minus and this is plus. So V2 minus V1 is equal to 18 volts, which is equation number 2. So second equation we got. The first equation is this one. The second equation, by considering the super node, that is V2 minus V1 is equal to 18. So if you solve these two equations, I am going to get V1 is equal to 2 volts, whereas V2 is equal to 20 volts. V2 is equal to 20 volts. So this is super node concept. Now here see this example in which there are two super nodes. So one super node is with dependent source, one is independent source. See this example. Between the nodes 1 and 2 a voltage source is connected. So here we are forming a super node. And between 3 and 4 there is a dependent source. So that is also a super node. Whether it is a dependent source or independent source, treat it as a super node. So let us write the node equations first. How many super nodes? 2 super nodes. So we will get 2 KCL equations, 2 equations. So considering a super node which is formed by making the nodes 1 and 2. So by clubbing 1 and 2 nodes as a single node, so writing the KCL equations, 2 ohms is carrying current towards the node. So entering means plus. So how much it is? It is reference is, so 0 minus V1 by 2. Then this 10 amperes is also entering, so plus 10. Then the 6 ohms current is leaving, so minus, how much it is? This is V2 minus V3 by 6. Then this 3 ohm resistor is also connected to this super node which is leaving, so minus V1 minus, so this is 4, V4 by 3 is equal to 0, is equal to 0. So simplifying this equation, I got this one. Next, this is the super node. So see, this is plus and minus, this is 2 and this is 1, and its voltage is given as 20 volts. So what we have to written here? This is V1 minus V2 is equal to 20 volts. V1 minus V2 is equal to 20 volts. This is equation number 2. So this comes under the super nodes which is formed by clubbing the nodes 1 and 2. Now if you see the nodes 3 and 4, there is also a dependent source or dependent voltage source, right? So in this case also a super node is formed here. So that means at super nodes 3, 4, see, so what are the currents entering and what are the currents leaving? So 6 ohms is entering, so that is V2 minus V3 by 6. Next, then this 4 ohms is leaving, 4 ohms current is leaving, that means minus V3 by 4 leaving, so minus. Next, then this current 3 ohm resistor is having entering current, so plus, that is V1 minus V4 by 3. Then whereas coming to the last one, that is this one, that is V4 by 1, which is also leaving, so leaving, so minus V4 by 1. Now if you see this super nodes 3 and 4, there is a dependent source whose value is 3Vx, so this is V3 and this is V4. So what is the polarity? And this is plus and minus, this is plus and minus. So from this what we can write? This is plus, so V3, this is minus, so V4, how much it is? 3Vx, 3Vx. What is Vx? So if you see the circuit, Vx is given as the voltage across 3 ohm resistor, the voltage across 3 ohm resistor. What is the voltage across this 3 ohm resistor? It is connected between node 1 and node 4. So it is V1 minus V4 by 3. 3 into V1 minus V4. If you write by 3, that means resistance, you have to again multiply it with current to get the voltage. So this is 3 into V1 minus V4. V3 minus V4 is equal to 3 into V1 minus V4. This is equation number 4. So see, this is equation number 3 and equation number 4. So 4 equations, 4 unknowns, so you can calculate all the 4 parameters. So 4 equations are eliminate one, either V3, V1. So V3 is equal to V1, that means if you substitute in all the equations, you will get in terms of V1, V2 and V4. So solve for V1, V2, V4. So I got V1 as 15.38, V2 minus 4.6, V4 minus 1.538, whereas V3 is same as that of V1, so it is also 15.38 ohms, right? This is about the nodal analysis applied to dependent sources. So with this I conclude the nodal analysis with dependent sources. Thank you. Thank you very much.